Okay, so let's simplify radicals. When you have an irrational square root, not a perfect square, what you're going to ask yourself is what perfect square divides this number, okay? The bigger the perfect square, the better. We'll talk about that in a minute. But if you find any perfect square that divides the number, you're good. So the square root of 50, what perfect square divides 50? 25 does, and it's 25 times 2. Now, there's actually a split here that we won't always show, but this is the square root of 25 times the square root of 2. You can split that up. The square root of 25 is 5. 2, the square root of 2 is irrational. It stays under the radical. So typically, we will go from here to here. You can show this step if you need to, but you don't have to. Square root of 25 is 5. Square root of 2, can't do anything with it, we're done. So the square root of 50 simplifies to 5 root 2. Okay? If there's a number already outside the radical, and I'm going to show you two ways on this one to see what happens if we don't get the biggest perfect square. Let's say we're looking at the square root of 80. We know that 4, which is a perfect square, divides 80. So we say 4 times 20. Well, this 2 is already out here. The square root of 4 is 2. Remember, there's this split step here that we're not always going to show. And then I've got the square root of 20. So you multiply by what's already out there, and you get 4 root 20. And you think you're done, but is there a perfect square that divides 20? You always have to ask that. Is there a perfect square that divides the radicand? And in this case, there is. 4 does again, and it's 4 times 5. This 4 is already out here. The square root of this 4 is 2. And then the square root of 5 is stuck, and we end up with 8 root 5. Okay? Now, could we have done that a little quicker? Well, there's a bigger square, bigger perfect square than 4. 16 divides 80, and it's 16 times 5. 16 times 5 is 80. So this 2 is already out here. The square root of 16 is 5. The square root of 5 can't do anything with. 4 times 2 is 8. 8 root 5. Guess what? We got the exact same answer. It just took us a little less time to get there. It's sort of like simplifying fractions. If you have a fraction with great big even numbers, you can divide by 2 over and over and over again. Or you can divide by 4 or 8 or 16 or bigger numbers and get there quicker. So the bigger perfect square you use, the better. Here are two for you to try. The square root of 27 and 7 root 28, or 7 times the square root of 28. See if you can simplify these, then check your work. If I did it correctly, I got 3 root 3 for the first one and 14 root 7 for the second one. If you have any questions, ask them, and we'll go on to the next thing. In general, when you're multiplying radicals, what you look for, you multiply the coefficients and then you multiply the square roots. And there's lots of ways to do these. You can simplify before and then multiply. You can multiply and then simplify. You should end up at the same place. You should do what makes sense to you. So basically here what we're going to do is we're going to put the 6 and the 3 together, and we're going to put the square root of 2 and the square root of 2 together because they're the radicals. So 6 times 3 is 18. The square root of 2 times the square root of 2, you multiply the radicand, so that's the square root of 4. So that is 18 times 2 because that simplifies, and we get 36. Make a note here, a square root times itself equals the radicand. The square root of 2 times the square root of 2 is going to be 2. Okay? This next one, 2 root 3 times the square root of 5. The 2 doesn't have anything to multiply by. The square root of 3 times the square root of 5, since those are both square roots, we can multiply those together and get the square root of 15. We always need to ask, is that simplified? It is. There is no perfect square that divides that. We're done. Okay? So this one, these are all square roots. Square root of 2, square root of 9, I'm sorry, square root of 2 times the square root of 2 times the square root of 9. So we can multiply that all together. I'm going to show this to you two ways. We can multiply that all together, 2 times 9, because they're all square roots. That's 4 times 9, so we get the square root of 36. Square root of 36 is 6. Always simplify. Or we can look at this and say, well, the square root of 2 times the square root of 2, that's going to be 2. The square root of 9 is 3, and 2 times 3 is 6. So multiple ways to get there, you should get the same answer. But in general, multiply the coefficients together, multiply the square roots together. Don't forget to simplify your answer. This could show up in problems like we've been doing with polynomials, just that instead of variables there will be radicals. Here I'm going to distribute that root 3. A couple of ways to do this, but I'll show you probably the most straightforward way. The square root of 3 times the square root of 3, those are both square roots, so I can multiply them together and get the square root of 9. The square root of 3 times 4, this is in the radical, this is not, so all I can do is write it like this, minus 4 times the square root of 3. You sort of treat radicals like you treat variables. This would be like x times negative 4, and we'd get negative 4x. That's one way to do it. Now, is there anything we can simplify here? The square root of 9 is 3. I can't do anything with 4 times the square root of 3. I'm done. Adding and subtracting radicals, you treat radicals like you treat variables. Two radicals have to be the same thing. They have to be like terms in order for you to combine them. So if I have 3 root 5 plus 4 root 5, this is just like 3x plus 4x. 3 root 5 plus 4 root 5 is 7 root 5. Always check, can you simplify the square root of 5? You can't. So I look over here, 4 root 3 minus 2 root 7 plus 8 root 3. I look for my like terms, 4 root 3 plus 8 root 3. That's sort of like 4x plus 8x. So I get 12 root 3 minus 2 root 7. Those are not like terms. I'm done. That's as far as I can go. So all that's pretty boring. So they will give you some stuff that you have to simplify. These, you can't do anything with this if these don't match. So they're going to make you simplify before you can combine. As a clue, look at your simplified radicals. If this has got a 2 on it, or 2 under the radical, I'm going to have to end up with a 2 here probably in order for this to work. Okay? So the 3 root 2 I can't do anything with. 3 root 50, what perfect square divides 50? 25 times 2. Look, my 2 showed up. I was expecting a 2 to get these to match. Now I've got to clean it up. This is going to be 3 times 5. Square root of 2 is stuck. Can't do anything with it. I get 3 root 2 plus 15 root 2, which happens to be 18 root 2. Okay? All right, let's look at the next one. 3 root 24 minus 2 root 6. Are either of those simplified? Square root of 6 is simplified, right? There's no perfect square that goes into 6. So that means I'm probably going to have 6 go into this here to end up with a square root of 6 here. So what perfect square divides 24? Happens to be 4. 4 times what? Guess what? A 6. So I have 3 times the square root of 4 is 2. Square root of 6 is simplified. Minus 2 root 6. So 3 times 2 is 6. 6 root 6 minus 2 root 6. I can combine those because they're now like terms. And I get 4 root 6. So sometimes there may be more than 2 terms. Simplify everything. Combine your like terms. So the square root of 8. What perfect square divides 8? 4 does. So that will simplify. Minus 4 times what perfect square divides 32? 4 does. 16 does. Always go with the bigger one. So square root of 2, can't simplify. So now we keep cleaning up. The square root of 4 is 2, square root of 2 is stuck. Minus 4, square root of 16 is 4, square root of 2 is stuck. Still can't do anything over here yet. Then I get 16 root 2 minus 16 root 2 plus 3 root 2. Well, 16 root 2 minus 16 root 2, gone. That became 0. And I'm left with 3 times the square root of 2. Alright, the last thing I want to show you is what they can do with this that will look like what we've been doing in class with polynomials. Let's say I have, let me find a good example, 4 plus the square root of 5 times 4 minus the square root of 5. This is just what we've been doing in class. You're going to distribute. 4 times 4 is 16 minus 4 times the square root of 5 is 4 root 5. Square root of 5 times 4 is plus 4 root 5. Then I've got square root of 5 times square root of 5, that's minus the square root of 25, right? Those are both radicals, so you can multiply them together. Now you want to clean this up. 16 plus 4 root 5 minus 4 root 5 goes away, minus square root of 25 is 5, and I get 11. So that's simplified to just a whole number, right? What if I have 2 plus the square root of 3 squared? Well, this means 2 plus the square root of 3 times 2 plus the square root of 3. So we're going to do just like we've done two binomials. We're going to multiply. 2 times 2 is 4. 2 times the square root of 3 is 2 root 3. Same thing here. 2 times the square root of 3 is 2 root 3. Square root of 3 times the square root of 3 is square root of 9. Now we're going to clean this up. I've got a 4. These are like terms. 2 root 3 plus 2 root 3 is 4 root 3. And the square root of 9 is 3. Then these are like terms. And I get 7 plus 4 root 3. So it looks a little different, but it's just what we've been doing. Just remember when you can put radicals together and when you need to put coefficients together. One more example, just like multiplying two binomials. 5 root 2 times 3 root 2 is 15 root 4. 5 root 2 times a negative 2 is negative 10 root 2. Remember to treat those radicals like variables. 2 times 3 root 2 is 6 root 2, and 2 times negative 2 is negative 4. Now, see what you can clean up. 15 times the square root of 4 is 15 times 2. Minus 10 root 2 plus 6 root 2, those are like terms. You get minus 4 root 2, minus 4 tags along. A little more cleanup. And then 30 minus 4 is 26 minus 4 root 2. Multiply, simplify, combine like terms, you're done.